All right, guys, welcome to another episode of CUDA Education. We are still on the Compute Colon LOD script, although I sense that we are close to, being done with this script. We have learned a lot from it, and shout out to the author. Um, I'll have it linked down below, all of that good stuff. Um, but we still we still kind of need to just clean up some rough edges as it relates to our understanding, right? And one of the one of the things that's important for us to really get a grasp of is this idea of the the processing of data inside of the buffer, right? Vulkan to to give Vulkan data and have Vulkan do rational things with it, right? For us to be able to describe the data properly, to give it a good framework, so Vulkan knows what is where, when, and how, all of that good stuff. Um, it requires a lot of code. It requires a lot of typing and a lot of things, a lot of moving parts, and a lot of things are going on, right? The world is grateful for it because it gives us the ability to customize and optimize applications and scripts and things like that, so that it is it can be as efficient as possible, but it puts a burden on the user, the author, the coder to sort of do it. So I've sort of covered these topics several times now in my series of videos, but um, enough review. Several reviews isn't enough to really grasp and digest all that's going on. Um, there's just a lot of moving parts, and the more we investigate it and the more we see it, is the better we can understand it and appreciate why things are done the way it's done, and we get a better hang of how to proceed when we want to create something. um so as part of this, because this example deals a lot with a lot of instances, so it's instances of Suzanne, right? It's instances of an object, right? Which we could see right here. We see that it's several objects that are basically displayed. And then we could call the objects basically, and then when we call the objects, we don't, and then we could uncall the objects, right, and get back to what we were, right? All of these objects represent a lot of instances, right? So these are all instances, right? So we have vertex data, which is building the model itself, and then we have instance data, which is all of these objects that we see in our scene. Okay, so we have the unenviable task of having to basically communicate all this information in order to do that scene to Vulkan, right? So we got to provide the data for the meshes. Remember, guys, that we're not just dealing with one mesh; we're dealing with several meshes, right? So we're dealing with the detailed one, and then as we get progressively further down the line, we get less detailed meshes, right? So we're dealing with that. We're dealing with many instances of the different details of meshes. Um, we're dealing with updating and changing the mesh as we zoom in, as we zoom into the scene, right? Because these red things in the low level detail stuff, as the camera moves closer, it becomes high level detail, right? So you see that the red disappears and the orange disappears, right? So we, there's a lot going on, and what I want to do is just to kind of reiterate, on a very high level, what's going on. So Vulkan has this thing called the pipeline vertex input state, okay, and it has two sort of features in it. It has binding descriptions and attribute descriptions, right? So Vulkan, you can't just give Vulkan a blank USB stick and hand it over to Vulkan and expect Vulkan to do anything with it. It has to be sort of in this pipeline vertex input state format, right? So we have 8 megabytes of data here. Each block is 1 megabyte of data. And let's just say for our purposes, this is an old video that I did, but the whiteboard was relevant to sort of what I'm trying to tackle here in code. Let's say we have 8 blocks of data here, and we have vertex data, which is basically building each object itself, right? So we're building each of the models itself. And then we have instance data, which is, the position of all of the objects, the position of the object, the scale of the object. Yeah, right? So we have vertex data for each object, and we have instance data for, we have vertex data for each object, and then we have instance data for basically vertex data for building the object, and then instance data for where the location and scale of each of the objects, right? So we have one block of data, 8 megabytes, and I'm just using this because running with this because this is what the whiteboard has, right? So let's say we had 8 blocks of data, and each block is a megabyte. So we go from 0 to 7, right? We break up this 8 megabytes of data into bindings and attribute descriptions. So bindings kind of section off, it's like a high level section off of the data. And then attribute descriptions is the low level per megabyte individual description of the data. Okay? So in the example that we have here, we have, and also the compute colon load, we have we have data that's transferred to Vulkan, right? So a blank USB stick that's transferred to Vulkan, but now we're trying to describe what we're sending over. So we have a binding of 0 and 1. We have a binding. We have vertex data and we have instance data. Okay, and we associate binding the vertex data with binding 0 and the instance data with binding 1. Okay. So we now sectioned off our 8 megabyte into 4 megabyte pieces, right? I'm mixing this what I see on the whiteboard with what's in our example, but I'm sure you could follow my drift. So we have 8 megabytes of data. We separate out the data into bindings. So we have a high level binding of binding 0, and we have a high level binding of binding 1. Okay? Binding 0 represents vertex data, binding 1 represents instance data. Now, inside of each of these megabytes, right, individually, we have more descriptive information. So we have a thing called attribute description. Okay? So in each one of these megabytes, we have specific information as it relates to that specific megabyte, right? Attribute description, I would assume, doesn't necessarily care about what binding it resides in. It's just concerned with its megabyte of data and what it's describing, right? So notice here that for the section that we're dealing with in vertex data, which happens to be associated with binding 0, that we have in this whiteboard case, the data looks black, right? And then for like megabyte 5 and 6, over here, the attribute description, the data looks pink. Okay. So attribute description is just dealing with, the actual byte of data itself. It's a granular thing. Okay. Binding description now is more high level. It's sectioning off data into vertex data and instance data. Now, because the bindings are high level, on the binding side, we know that, okay, each megabyte of data in binding 0 is consumed on a per vertex input rate. So every vertice in our application is going to consume these 4 megabytes, right? That's my logic. That's my understanding. So each vertice is going to consume these 4 megabytes of data. Okay. Each vertice. So remember, the mesh is made of many vertices. A triangle is made of 3 vertices, right? So each vertice is going to consume these 4 megabytes of data. Okay. And that is associated with binding 0, right? So we section off the data, we have a binding, and then we in the binding description we declare, okay, this piece is going to be consume these 4 megabytes of data on a per vertex case. All right. So that's block 0, 1, 2, and 3, right? 4 megabytes. Block 0, 1, 2, and 3. Conversely, blocks 4, 5, 6, and 7, which is associated with binding 1, is going to be consumed on a per instance basis, what they call per instance input rate, per instance basis. So these blocks are going to be consumed per object. Okay, so let us run the application again, and we'll sort of cross-reference in a rough way. We'll sort of cross-reference what is what. So binding 0, vertex data, it's gonna be the mesh that makes up this the mesh that makes up this I'll just collapse this a little bit more. Okay. Right. The mesh that makes up this object, right? So I'll just freeze for now. The mesh that makes up this object, right? So all these vertices, it's a lot of vertices, like 10,000 plus, I think, vertices that make up this object. All 4 megabytes for each one of the vertices, all 4 megabytes are consumed for each one of the vertices, okay? And that's dealing with a per object thing. You notice that, of course, again, when we scroll back down, these ones are lower level of detail, so the meshes are less intricate. But the fact still remains, we're consuming these four megabytes of data on for every vertex in here. It will be less vertices, right? But for every vertex, we're consuming these blocks. Okay, so let's go back to where we were. All right, so on the instance side of it now, so these 4 blocks, 4, 5, 6, and 7, these blocks, we're not consuming on a per vertex data. So it doesn't care about how many vertices are involved in creating this object. What it does care about is per instance. So we have an object, and then you can have one instance of an object, or you can have many instances of an object. So instance 1, let's say instance 2, instance 3, instance 4, instance 5, as we go along. So now these blocks, it's just 4 blocks are consumed per instance or per object, right? It's not dealing with per vertices, it's dealing with per object, right? And we did that in a previous video where we messed around with how the data was consumed, and when we changed this from per instance to per vertice, we got like a bunch of like garbage rendering, because now it was basically trying to do an instance per vertex or whatever. It was just a mess, right? And that's pretty much what the battle that we're tackling, right? We have per instance, and we have per instance and per vertex data. right? So per vertex again deals with one object, per instance deals with you know, basically each object, right? The vertex data is 10,000 vertices per object, right? But instance data is we're consuming 4 blocks one time for each instance, okay? Um, so now we have to go through the unenviable task of plowing through the code to sort of understand what's going on here. Just as a means of us understanding what's happening. So notice here we have so we'll just we have binding 0 per vertex rate, right? And this is in the binding descriptions, right? So per vertex rate, binding 0, right? Now this makes sense for us because we know that um, for the right, we know that for the bindings we have binding 0 vertex data, right? Per vertex data. So we have vertex input binding description, right? Binding description. We have, what is the signature for it? We have the binding, which is 0, and then the stride, which is basically per vertex. It's like, whatever the vertex, and then vertex input rate vertex, VK vertex input rate, and it's the vertex, right? So this now binding 0 is being consumed on a per vertex basis. Furthermore, binding 1 now, which is this, is we're still binding description, vertex input binding description. We're now at binding 1, and now this is marked as vertex input rate instance, right? So we're dealing with the instance, and we're consuming this per instance. Okay. So that sort of follows with what we had initially described. Now we get into, so that's a binding description. Now we get into the attribute descriptions. Okay. So the attribute descriptions now goes a little one step deeper. Let us look at the signature for this. So again, we have bindings, and we have so we have bindings, and then per vertex we have let's see now. We have position, normal, and texture coordinates. Position, normal, and texture coordinates, right? So on this is going to be binding 0, location 0, 1, and 2. We're not going to get into location right now, but let us, I guess the location would be each particular block, right? 0, 1, and 2. Okay, so we're still at binding 0, which is consistent with what we expect because this is vertex data. And we're dealing with per vertex attributes. These are advanced for each vertex fetched by the vertex shader, right? So we are dealing with attribute descriptions, AD, attribute descriptions, right? We're dealing with each specific block. Binding 0, location 0. Binding 0, location 1. Binding 0, location 2. All right? I know my example, it was a different example, but location 0, 1, and 2, we now are going to say for location 0, it's a position. For location 1, it's a normal. And for location 2, it's the color. Okay? And we can see that this is per vertex, right? So all of these vertices that make up the object we have to deal with position, normal, and the color or the texture coordinates, right? So location 0, 1, and 2. Okay. Now let us deal with the instance side of it. Now I apologize, guys. Of course, the images don't line up, but we have binding 1, which is consistent with our image, binding 1, and then location 3 and 4. So let's just deal with location 4, right? Location 4, in the attribute description, we're going to set that as the scale, right? So it's the size of the object, okay? For here, location 3, I know it's not consistent with the image here, but for location 3, which is under binding 1, it's going to be the position of the object, right? So here we're dealing with an individual object. Here we're dealing with like implicitly the object itself. Here we're dealing with the location of the object and the size of the object, right? So location 3 is going to be the position, and location 4 is going to be the scale, right? And then we just, then we do a bunch of stuff. Okay. But I just wanted to reiterate this because it's very important. Um, do we um okay, right? So attributes descriptions, we're just handing over the data and we're creating the graphics pipeline, which is a whole nother discussion, right? But all right, so it's not too bad, guys. It's not too bad. We're initializing attribute descriptions, and then we're loading up data for attributes descriptions, and then um, we consume it in the input state, and we do all of this work because we have to create the pipeline, the graphics pipeline. Okay, so that is what that is. That is what that is. Okay. But I wanted to create this video because we really needed to understand, and this is all under the prepare graphics function, right? So we notice that all of this stuff that we're talking about here, vertex data and instance data, it's concerned with the graphical side of the equation, right? We're not, but this doesn't, dealing with the data and all that the USB stick has and stuff, all of the data. It's not. This is not being consumed on the compute side. It's being consumed on the graphics side because we need to figure out, you know, how to basically build the objects and where to put the objects, right? And so, for whatever it's worth, know that this vertex data and instance data is dealing with the graphics side of the equation. Let me see. Okay, right. So, right, we're dealing with the graphics side of the equation, which makes sense, right? Because we're building objects and we're putting objects inside of a scene, right? We're building objects and we're putting the objects, we're sprinkling it all over the scene, right? So this is our, maybe if I freeze, freeze. All right, these are all of our objects, right? You understand? So that's that. Anyway, that is the conclusion of this video. But I hope you guys have a better appreciation for all that's happening here. It's actually, just remember whenever you see binding description, attribute description, all of that stuff, we're talking about we don't want to be in a position where we're handing a blank an unlabeled USB stick to Vulkan. If we hand data to Vulkan, we have to label it properly. It's almost like someone hands you, 10 gigabytes of data, and the data is just like one big file, and the file doesn't even have a name, and that one file is 10 gigabytes, and where someone else gives you a USB stick with like proper labeling of the USB stick itself, proper labeling of the different files on the stick that adds up to maybe 10 gigabytes of data. And then each of the documents on the USB stick is broken up into folders so that the other person that's receiving the data can make good use of the data, right? You never want to be in a position where you're giving Vulkan basically just you're just giving Vulkan data, and it doesn't have a framework to receive and process the data, right? So that is what pipeline vertex input state, binding descriptions, attribute descriptions is tackling. All right. So guys, as always, support the channel, like, subscribe, tell your friends. Tutorial number 1 is for installing the Vulkan SDK on your machine, on your Windows-based machine with a Vulkan-capable GPU. Tutorial number 13 is involved with installing all of these examples, including this one. Now, these examples also include ray tracing examples. If you want to be able to run the ray tracing examples, you need to make sure your GPU is also ray tracing capable. For the NVIDIA cards, it's RTX series and later and greater. For AMD and Intel, I don't know. You're gonna have to figure that out. Look up what GPU you have and what are the capabilities of the GPU. Most likely, it's already Vulkan capable, but the ray tracing piece is fairly recent. So, uh, you know, don't worry if your GPU is not ray tracing capable. Don't worry if your GPU is not ray tracing capable. There's still this example and many of the examples that I go through. Um, it doesn't involve ray tracing examples. Um, I mean, there is a series that does involve the ray tracing stuff, which if you can, it would be great for you to get a ray tracing capable GPU. But that's it, guys. Learn to program your GPU. Learn to program your GPU. Learn to program your GPU. It is the future. Thank you guys for watching. Have a great day.